11 methods. We're going to look at exercise 5F, question 9. Find the set of values for k for which that is greater than 1 for all of x. Okay, so you want to find the value of k such that f of x is always greater than or equal to 1. Okay, so what you're wanting is 3x minus 5x minus k is greater or equal to 1. Now, we're going to have to draw on, now this chapter is actually drawing on knowledge from quadratics. And remember, I can move the 1 to this side. So I can go 3x squared minus 5x minus k minus 1 is greater than or equal to 0. Now, this is asking you, when is that graph positive? Okay, when is that graph greater than or equal to 0? Now, remember back in the day where we looked at discriminants, okay? So we want the discriminant for this graph to be greater than or equal to 0. So we want one solution or two solutions, okay? So we want to find what value, so we want the graph, so this graph in particular, to either touch once here or not touch at all, okay? Not touch at all. So let's see, and it's a positive graph, so it can only look like that or that. So we want to find the discriminant. So discriminant is given by b squared minus 4ac. We've got b, my b value is -5. -5 squared is 25 minus 4ac. C is my negative k minus 1. Okay, and you want that to be, so we want it to have either no solution or one solution. So it has to be less than or equal to 0. Remember, discriminant, one solution means equal 0, no solution means less than 0, and more two solutions means greater or equal to 0, greater than 0. So all I'm going to do is I'm going to solve this on my CAS. Okay, so I'm going to go on my CAS. I'm going to go 25 minus 4 by 3. I'm just going to use x as for convenience. X minus 1 is less than or equal to 0. So go match 3 to get less than or equal to 0. Interactive and solve. Interactive and solve. And k has to be less than or equal to negative 37 and 12. K has to be less than or equal to negative 37 and 12. Done. Show that the minimum, show that for all k, the minimum value of f of x occurs when x equals 5 and 6. Find k if this minimum value is 0. Okay, so shows that, so we know it's a minimum because it's a upright parabola or a smiley face, and okay, so we want to show that. Show that means show step by step. The minimum value occurs at 5 on 6. So we know that f of x equals 3x squared minus 5x minus k. To get the minimum turning point, you can do it both ways. You can scaffold first to get the turning point form. So you have to take the 3 out first, remember. Whenever there's a 3 in front of the x squared, you need to take it out first. So I'm going to take out the 3 first. 3 minus 5 on 3x minus k over 3. Okay, so this is going to be, it's not going to be a nice one. So I'm going to scaffold inside now. So I've got x minus 5 over 6. Minus 5 over 6, square it, that's 25 over 36, minus k on 3. Okay, oops, keep going. Let's keep going, simplify. So x minus 5 on 6 squared. Now, this is a bit tricky. Okay, it's tricky because we need to multiply this by 12 and this by 12 to get being 36. So 25, okay, so this is the minus 25 minus 12k on 36. Okay. Now I'm going to multiply everything by 3, so I got 3x minus 5 over 6 squared. This will be minus, I'll just put a bracket, 25 plus 2k on, now I multiplied by 3, so that should be 12, okay? Now, okay, so we've got the turning point form, so the turning point would be at 5 on 6, negative 25 plus 2k, 12k over 12. That's my turning point. So I've shown that the minimum value occurs at that, so that's fine. And then find k if the minimum value is 0. Okay, so find k if the minimum value is 0. So the minimum value is 0. So we let that part equal 0. Okay, because this is the value of x when we have a minimum, but this is the actual minimum value. This is referring to the y value. So all you have to do is go negative 25 plus 12k on 12 equals 0. So you let it equal 0 and you find yourself for k. So go on CAS calculator. Go, right, so I'm going to go negative button, fraction, 25 plus 12k, 12x divided by 12 equals 0. Interactive and solve. And x equals negative 25 on 12. So k equals negative 25 on 12. Okay. So again, a tricky question. Okay, so you needed to know how to deal with the discriminant. Okay, so when you have a quadratic greater equal to 0, it either means it equals 0, meaning it touches it once, or it doesn't touch it all, meaning you have, in terms of solutions, you either have one solution or no solutions at all. Okay, and for the next part, you've got to show how to get this into turning point form and get the turning point in terms of k. So we've got turning point for x is 5 on 6, which is what we've shown. And we got to make sure that the y coordinate, because it says the find k of the minimum value, so the minimum value is the y coordinate equals 0. Okay, and you solve for k there. So hopefully that helps.